Hello there and welcome to Lower 6 Maths A-Level Practice Paper C. Here we're working on question 9, a modelling question. A stone is thrown from the top of the cliff. The height h in metres of the stone above ground level after t seconds. So if we have the cliff here and if we have some person on top of the cliff throwing a stone, she is going to throw it upwards, and then afterwards gravity is going to take over and bring it back downwards. So this is why it's going to look like a sort of quadratic graph upside down, so it's a negative quadratic graph. That makes sense. Give a physical interpretation of the meaning of the constant 115 in your model. Okay, so what 115 is going to refer to is if I were to use the value of time equals 0, so no time has passed, this expression here would be 0, this expression here would be 0, so h of 0 would just equal 115. So the interpretation of 115 is this is the initial height above ground level. So in terms of what a real life model would put this at, is it would be the height of the cliff plus the height of the person who's throwing the stone, or from where their arm is from where they release the stone. Okay. Part B is write h of t in the form a minus b bracket t minus c squared. Okay, so what we can do here is we're going to need to basically complete the square here. So what I'm going to look to do first from this h of t 115 is to factorize out a negative from the last two terms that involve the t and the t squared. So minus 4.9t squared plus 12.25t. Okay, so the next thing I'm going to do is now pull out 4.9 from both of these terms here. So minus 4.9, and I'll be left with t squared, and 12.25 divided by 4.9 gives me 2.5t. And from here I'm now going to complete the square with this expression here. So 115 minus 4.9, that's going to give us, so what you do with completing the square is you do t minus half of 2.5, so that's 1.25 squared, and then you subtract 1.25 squared, so let's think of 1.25 as 5 over 4, so this is going to be subtract 27 over 16, so 25 over 16. Okay, so what we need to do now is we're going to need to expand the bracket slightly, so it's going to be minus 4.9 times the bracket of t minus 1.25 squared, and then expand the bracket with the 4.9, and what you're going to get there is 4.9 times 25 over 16 is going to be 7.265625. Okay, and then what we're going to need to do is add that on to the expression at the front. So that's going to give us 122.65625 minus 4.9t minus 1.25 squared. Excellent. So what we need to then write here is just finish it off and write a is 122.65625. B is representing here 4.9. and C is representing here 1.25. Okay, great. C, find the time taken after the stone has reached for it to reach ground level. Okay, so what we want to do here is find the time it takes to reach ground level. We're going to want to set this function here equal to 0 so that the height is effectively then 0. So this is going to mean that 122.65625 minus 4.9 bracket t minus 1.25 squared equals 0. Okay, so what we'll then do is add that over to the other side and divide by 4.9. So 122.65625 divided by 4.9 equals t minus 1.25 squared. Square root both sides and add the 1.25 onto the other side, and you get roughly on your calculator, so 122.65625 divided by 4.9. Square root that answer, and then it's going to be positive or negative, but we're probably going to only want the positive there. Add on your 1.25, and that's then going to be 6.25 seconds. Okay, so after 6.25 seconds, it's going to reach ground level. Find the height of the stone above the ground level and time at which it takes to reach a maximum height. Okay, so now we're looking for the maximum height. This clue here gives us quite a big clue, really. If we've got a subtraction here of something squared and we want to maximize this function here, then we want for this bracket here, the squared part of it, or the positive part of it, to be equal to 0. So what we want is t minus 1.25 to equal 0, so that we can maximize this whole function here. So t is going to have to equal 1.25 in this case here, and when this is at a maximum, this expression here is going to be 0, so we're not taking away anything, so the maximum height is going to be 122.7 meters, roughly. Okay, great. That's 9 marks for that question.